Hello friends, in this video we will implement custom controller factory to support dependency injection. Now what is controller factory? Controller factory is responsible for creation of controller instances in a request pipeline. The default controller factory class is the default implementation by MVC, but we can extend it as per our requirement. The base interface for controller factory is iController factory. Now default controller factory class, as I mentioned earlier, is the default implementation provided by MVC. The class tries to find out the controller class that matches the controller parameter in the route values, create its instance and returns back to the pipeline. So let's see MVC pipeline where the controller factory comes into the picture. So the request comes in, the URL routing module is the HTTP module which intercepts a request. It selects the matching route from the route table which you register in the route config, and once a matched route is being picked out, the attached MVC handler is being picked from the route. Basically under the hood it attaches a MVC handler using the map route method. Whenever you're calling the map route method, you are basically attaching the MVC handler. So then once the MVC handler has been fetched from the route, you are calling process request method. This process request method calls the controller factory. Now the MVC runtime returns the default controller factory if there is no custom controller factory being registered to the MVC. So in that case, the default controller factory creates the controller instance based on the route parameters, and then the controller's execute method is called, which calls the action invoker and which calls the action method based on the action name, and finally result is being generated and returned to the UI. So this is where the controller factory comes into picture, and it generates the controller object and returns the object, and then the further process goes on. So we are going to customize this controller factory. So let's move further. Now iController factory, this is basically the base interface for this class. It has basically three methods, out of which the create controller is the most important one, which is responsible for instance creation. The parameter to these methods are request context object, which allows the factory to inspect the detail related to request, and the second parameter is the name of the controller. Okay, now how to create basically custom controller factory. Now in order to create your own custom controller factory, you can follow one of the below methods, with later one more easy to use. Okay, the first method is by implementing the iController factory interface. You can implement the three methods which is defined by the iController factory interface, or secondly you can inherit default controller factory class. Now this class has virtual functions, so it provides a default functionality and also provides the user to extend those methods by using override. So you can override this functions of this class. The second one is more easy to use. How to register? Now once you created your custom controller factory, you have to register it with the MVC, otherwise it will always use the default controller factory. So you can do that registration part in application start event of the global.tsx. We'll do that once we create our own custom controller factory. Now why custom controller factory? Now the possible reason is to implement the dependency injection, that is to pass the dependencies the home controller requires through constructor injection. So we'll see how we will implement dependency injection. So now I have a ASP.NET MVC4 application wherein I have a home controller. Now inside this controller I have created a simple scenario wherein I have an index method which, depending upon a variable value, calls the database logger or the text logger. So this is the variable basically, that is where to log. Now the value for this where to log comes from a static method. This static method accesses the web config. Now in the web config we have a key that is placed to log. If it is 0, it will log to text file, otherwise it should log to database. So based on that configuration, we are returning text or database based on the config value, and this variable is, we have set this variable in the constructor because in that case this variable is global and will be accessible to all the action methods. And now this variable, if it has value database, then we are creating object of type loggerdb, and then we are calling the log function of this class that is basically logging to the database, and if it is text, then we are logging it to the text file using logger text class. So if you go to this log function, so let's verify the log function also. So we have a logger class, which is the model class for logger db, and inside this we have three properties, that is logger id, logger text, and logger dt to capture the date time. And inside this we have created a context class as well, so we are using code first approach. So we have created db set of type logger, and the MVC generates the database for us. And if you check the database, we have a loggers table, and inside we have three properties as mentioned in the model. And if you verify the log function of logger text class, so in that case we are using append all text function of file class to log to a txt file which is present at my desktop, and we log the message to this txt file. So this is the simple scenario, and we'll see what are the problems involved in this code and how we are going to resolve. Now first check whether it basically logs the data or not. So if I check my logger txt file, currently it has single log present in the txt file. Now once the view is rendered, yeah, it has rendered. Now if I check it, there will be two. You can see there are two, as we have configuration set to 0 in our config file. Now let's review the code. If you check the section method, now this code is very redundant in the case. Now if you have another action method, you have to write this logic again to log or to check, to create the classes of logger, so that you can either log to database or log to a text file. So basically this logic you have to repeat again and again in every action method. So basically you are violating the usability concept. Okay, now there's one more problem. The other problem is basically this home controller class depends upon both of these classes. Okay, and there is no interface implementation, there is no abstraction implemented, so that the home controller knows everything about these two classes. Okay, so we need to implement abstraction as well. And there's one more problem. The other problem is, the last problem is basically this class, the home controller class, and this index method is tightly coupled to these changes or these conditions. Like if you have one more logger in the future, so you have to write one more else if. So in order to introduce one more logger, you have to make changes in the home controller. So in order to make changes in this, you have to make changes in the home controller also. So that specifies, or that constitutes, a tightly coupled application. So in that case, you have to again test this index method whether it is working fine or not. Okay, so that we have to do. So these are the failure scenarios, that is, it is tightly coupled, there's no abstraction being implemented, and this code is redundant, this code is not reusable. So we have to achieve all these three things using this, and we will also implement dependency injection. So now let's start with the implementation of abstraction. So in order to implement abstraction will have a interface. So I'm going to add one interface, and I'm going to name it as ilogger. Okay, and inside this interface I'm going to have a single function, that is log, which my current classes are using, and this function will accept a parameter of type string message, and I'm going to implement this interface to both of these classes. Okay, and to my other class as well. Okay, now let me build my application to check whether it is building fine or not. Oh, it is showing me one error. I included semicolon, sorry for that. Let me build it again. Yeah, it built successfully. Now instead of creating this logger object again and again inside the condition, I'll create it once outside, that is extending dot custom dot ilogger logger equal to null. Okay, so we have done one thing, that is abstraction is being implemented, at least for this code. We'll see how we can implement abstraction for entire home controller class. Now if you see, this action method is dependent on these conditions, and these conditions are redundant because for every action method we have to repeat these conditions. So we'll remove these conditions from action method and we'll put it to a common place so that every action method should access it. So likewise we have done for this variable. We'll paste the entire logic here, and okay, so the conditions for finding which logger to call is done at the constructor level, and then we can only use the logger object here. Okay, there's one more problem here. I have to make this variable global, so I'll create a private global variable. Okay, and then I can use this variable in any action method. So now I can write here, that is logger dot log, and I can log whatever action message I want. Okay, now the dependency has been removed from this index method, but it is shifted to now to the constructor. Okay, now we want to remove this dependency from this constructor, because if I have one more controller, in that case also I have to write these conditions. So basically we'll be doing redundancy of the code, plus this controller is tightly coupled to this code as well. So we want this conditions to be implemented a class above, a level above the controllers. So we'll comment this for now, and what we should do is we should accept a variable of type ilogger in this constructor, and we should have underscore logger here, and we should assign our private variable with the parameter we are accepting. Okay, so this should be the design. So how this design helps us is, we'll see the usefulness of this design. Now this home controller doesn't know about the implementation of this ilogger. So basically we have implemented a complete abstraction for this class. Home controller only knows that we are accepting object of type ilogger. The implementation behind it, this class doesn't know. So this is the abstraction scenario. It only knows that there's a APIs, that is there is a API that is log this class has to use. Okay, now this logic we are going to move it to a class above controller class, so that that logic will be common for all the controllers. You don't have to write this logic going to each and every controller. Okay, so we have removed that redundancy as well, and this code is now loosely coupled, because if you add one more source or one more logger, then you don't have to make changes in the home controller or test it again. Okay, so these three usefulness you have achieved, and there's one more use of this code is, now as you have implemented abstraction, so if you want to test this code, if you want to test the code for this action method, and suppose you are logging to the database, but while testing you don't want to log it to database actually, so what you can do, you can create a dummy class. Okay, and then you can implement this ilogger, and then you can write a dummy code inside that, so that you can test the code of this action method. So basically for testing purpose also this code is very useful. So now let's run this code and check whether it works or not. It is not going to work, but we'll find out the reason why it is not going to work, and how we can make it work, how we can achieve this design. Okay, so the exception it says is that no parameterless constructor defined for this object. This is basically when the default controller factory is creating the object of home controller behind the scenes, it is calling a constructor which is parameterless. Okay, which is being implicitly provided by the runtime. But as we have defined a parameter constructor, it is not providing it implicitly, because then in that case it expects us to create it explicitly. So in order to check this error, we have to create a parameterless constructor for this class. Okay, and you can also check here the flow of creation of controller class, that is create controller method is called for default controller factory, then get controller instance is being called, and finally the create function is called, which creates the instance. Okay, so now if you run the application, you won't get this error, but you will get another error. Like, just wait and check what error you get. Yeah, you can see this logger object or variable is null. This is because the default controller factory is calling the parameterless constructor. Let me check that as well. Let me run the application to check which constructor it is calling. Okay, you can see it is calling the parameterless constructor, but it is not calling the constructor in which we are assigning this logger object. So what is happening, this logger object is always null and you won't be able to access its API. So this is the default functionality of default controller factory. So what we are going to do here is we are going to create our own controller factory. So let's create it. So I'm going to add one class here and I'm going to name it as my controller factory.cs, and I'm going to inherit from default controller system.web.mvc.default controller factory. Now if you go to this class, you'll find that most of the methods are virtual, so that you can use the default functionality or you can override it. So we are only concerned with the create controller function, so we are going to override this function. Okay, and currently I'm going to comment this line, that is which is going to call the base functionality, and you can check it accepts the two parameters, that is request context and controller name. So inside this controller factory I'm going to create object of my controller. Okay, and I'm going to name the object as controller equal to new home controller. So now I have two options basically. Either I can call the home controller, that is parameterless constructor, which is a scenario for default controller factory, or I can call the second overload which accepts the iLogger object. So I'm going to call the second one because we want that iLogger dependency to be injected to the controller. So in order to do that, I'm going to create. So what we can do, we can inject that logic we have commented here. So that logic will be, we can shift this entire logic to here. Okay, so let me uncomment this logic and let me resolve the errors. Okay, now we have the logic to create the logger instance based on the config value. Then I'm going to pass this logger object to my constructor. Okay, and then I'm going to return my controller object. Okay, then there are no build errors. Let me build my app. So it is building fine. Now if you want, you can put this entire logic to a static function or a separate class to make it reusable and loosely coupled. Okay, and then that function will return object of type iLogger, and then we can pass that object here. But for now we are not doing that, but that is a suggestion you should implement. Okay, now the only thing remaining is that we have to register this controller factory. So in order to register this controller factory, we should register it in application start event. So here I'm going to use controller builder class dot current dot set controller factory, and I'm going to pass object of my controller factory. Okay, so we have registered it as registered the controller factory as well. So let me put a debugger here and run the application. So you can see it has called the create controller function. So the logic to decide which logger to call has been called, and then finally we are injecting using our second parameter constructor, and then we are setting the private variable, and then finally we are returning the controller, and then it calls the index method and the function is rendered and it has created the log in the text file. So this is how you can inject your dependencies through constructor injection to home controller class. Okay, so this is the one way. We can do it in another way, and that way is using the reflection. So in order to use the reflection, basically we have to get the type of controller first. So in order to get the type, so I'm going to use the type class, and I'm going to call it as type controller is equal to, there's a function of get type which accepts the string value. So we are going to format a series of string. So inside that, it basically requires the complete namespace. So the namespace of our home controller is this, so I'm supplying that. Then dot name of the controller, okay, which we are going to pass here, and then finally the controller name, that is the controller, and basically we get the controller name as home itself, so that is why we have to append controller as well. Okay, so this will get the type for us, and then using the reflection we are going to create instance. So we are saying create instance, and so it is basically accepts the type. So type is our type of, or we can pass this as well, type. Okay, and then we can also pass array of string, that is custom data if we want to pass. So we are going to pass a single value here, that is our logger object, and we are going to create it as system.web.mvc dot a controller, and we are going to return this controller. Okay, let's run it and check whether this also works. Okay, so let me skip the logic. The logger object is created and we got the type as well, and it will return the controller object as well using reflection. So we have used reflection to create the instance. So this is how you can achieve dependency injection using default controller factory. So let me again explain the things we have achieved. We have basically created a loosely coupled application here. We have moved the dependency from home controller. So we are just expecting a logger object which will be used for logging the things. So home controller doesn't know everything about the implementation, it just know the APIs of this interface. So this we, in using this, we have used the abstraction, and we have also moved the common code to the separate class so that every controller, it is executed for every controller. So basically we have removed the code redundancy. Now one more thing you can do here is, now not every controller want this as dependency. Okay, so we can have a check here as well. So what we can do here, so as we have a home, I mean controller name, so we can here check if my controller name is home, then only use the custom dependency code we have written. Okay, in the other scenario, what you do, you just call the default implementation. So this is what the use of inheriting from default controller factory compared to implementing all the functions of iController factory. So what you can do, whatever controller you want to call, or for whatever controller you want to call this custom code, you can call, and if you don't want to call for some other controllers, you can call the base functionality. So this is what we can achieve from default controller factory. Similarly, we can I'm also going to show how you can do it by implementing the interface. So let me create one more class. So I'm going to name it as my controller factory, interface. Okay, so in that case I have to implement the iController interface, and okay, so I have to implement all these methods so I can, okay, just a minute. Sorry, it's iController factory, and then we have to implement its all methods. So there are basically three methods: create controller, so we can copy paste this logic here, the entire logic. Okay, and for this state behavior I've already implemented it, so you can just include this code here. Okay, and in the release controller is basically method which releases the resources, so you can do in this way. Okay, so you can register this class and you can use this controller factory as well. So with using interface you have to implement these three methods. With using this class you just have to implement the create controller, and you can achieve loosely coupled, dependency injection, abstraction, and a controller which is easily testable. So these all features you can implement and achieve using extending controller factory and using dependency injection. So I hope you like this video. Thank you friends.